Midsegment theorem and coordinate proof. So our goal for this lesson is to use the properties of midsegments and to write coordinate proofs. So the midsegment of a triangle is the segment that contains the midpoints of the two sides of a triangle. So M, we can tell, is the midpoint of AB because AM and BM are congruent. And P is the midpoint of BC. We can see that because BP and CP are congruent. So therefore MP is a midsegment of this triangle. Each triangle is going to have 3 midsegments, and it's going to create a little tiny triangle inside the bigger triangle. And the midsegments of A, B, and C are MP, MN, and NP. So what does that mean? What are the qualities of a midsegment theorem? Well, your midsegment is going to be parallel to the third side, and it's going to be half as long as the third side. So that means that set midsegment DE is going to be parallel to AC. So all of the qualities of two parallel lines. In addition, DE is going to be half of the length of AC. So let's look at this first example 1. We've got a large triangular window, and in the diagram we are told that DF and EF are midsegments of triangle ABC, and we want to find DF and AB. Well, if DF is the midsegment of this triangle, then it's going to be parallel to BC, but it's also going to be half of BC. So I know that DF is equal to half of BC, which would be half of 90 degrees, which would be 45. AB is going to be twice the size of its midsegment. So FE is the midsegment here. It's parallel to AB, but it's also half of AB. So AB is equal to 2 times FE. So AB is equal to 2 times 45. So AB is going to be 90 inches. In example 2, we are given that QS is equal to QP. So I can go ahead and mark that on my diagram. And then I also know that PT is equal to TR. So now I've got this marked on my diagram, and what does that tell me? Well, I want to show that QR is parallel to ST. So if QS equals SP, then S must be the midpoint of QP. And if PT equals TR, T must be the midpoint of PR. So ST is a midsegment. ST is our midsegment. And therefore, QR must be parallel to ST by our midsegment theorem. All right, if we know that V is the midpoint, then first thing I know that these two segments, are congruent or equal. And then what do I know about SV? Well, I know that SV is a midsegment, so then I also know that SV is parallel to PR. All right, practice the 3 problems below and make sure you ask me questions if you don't understand them. All right, in number 6, PR is 16 feet, TU is 5 feet. Number 7, it should be 1, 2, and 3, but MN is 53, ZY is 14, and number 8, DF is 7, and BC is 12. All right, so a coordinate proof is just placing figures in a coordinate plane so we can prove things in general about their shapes. So we want to place an obtuse scaling triangle in a coordinate plane that is convenient for finding side lengths and assign coordinates to each vertex. So here's my obtuse scaling triangle, and that's my value P. I know it's at the origin because I placed it there. Okay, now this point up here, I'm going to call Q, and I'm going to give it arbitrary points, A and B. So that means I went A value or A units in the X direction and B values in the Y direction. So A, B. And then my last point is going to be C0, which means I didn't go up or down any, I just went C units to the right. Okay? Now let's apply some math to that. In example 4, I'm supposed to find a square. And the same thing, I'm going to give it some arbitrary points. But remember with the square, all of our sides are the same length. So if I start at 0, 0 and go up S, then I'm going to have to go over S. And then this side would also be a length of S. So all of my sides have a length of S. And we want to find the length and the midpoint of the diagonal. So if I draw a diagonal in here, and I want to find my distance, that's the distance formula. So my diagonal AC has a distance of S minus 0 squared plus S minus 0 squared, which gives us S squared plus S squared, which is the square root of S squared. And S squared, you can take the square root of that, but not of 2. So the distance, or the length of this diagonal, is S root 2. Now my midpoint theorem is the same as it was in Unit 1. So S plus 0, that's a typo, S plus 0, S plus 0, divided by 2. That gives us S over 2. So the midpoint of this line, of this segment, is S over 2, S over 2. Okay, so in the practice, you're going to be doing one example like example 3 and one problem like example 4. So go ahead and pause it and try to do those and then come back and look at the answers. Okay, so you've got an acute triangle with some vertices, and then an isosceles right triangle, and then you were to find the length of the hypotenuse and the midpoint of the hypotenuse.